And welcome everybody to the Daily Space Weather. We've got a coronal mass ejection watch in effect. I could say warning, I'll just say watch. An electron storm, Sunspot 2834, erupts onto the solar system's scene. Spring is ending, coronal holes. And here is the SDO colorized magnetogram, probably the most convenient way to look for sunspots in active regions. You see Sunspot 2833 up here, and Sunspot 2834 having just formed over there toward the northwestern limb. It'll receive a name today. If it hasn't yet been named, it's beta class. The likelihood of solar flares has gone up a little bit with that. Here's a full disk view in 171 angstroms, also from the Solar Dynamics Observatory, the SDO, the world's premier solar observatory. By the way, the sun didn't really speed up like that. We've just got some missing data there on the SDO feed. I'll let it play through one more time for your viewing pleasure. And we're delighted to announce that the Integrated Space Weather Analysis Center looks like it's fully functional now. At least everything I try to do on it works. We've got a spaceship trailing the Earth right now. It's called Stereo A. There's another one leading Earth at Lagrangian point 4 called Stereo B, but we're talking about Stereo A, which is chasing Earth orbitally speaking in this direction around the Sun. Let's try that again. Chasing the Earth in this direction around the Sun. Why is it called Stereo A? It stands for ahead, and it's because Stereo A is able to see space weather before it's visible on Earth. And there does appear to be some rising. Anyway, here's the feed from Stereo A at Lagrangian point 5. So from that perspective, Earth would be off to your right. And you can see a couple of large projections here of plasma out in the solar corona. We're expecting a series of coronal mass ejections to kick off here in the next day or two. So there's your coronal mass ejection watch. And here's a close-up of the northern hemisphere, where all of the sunspot activity is located, Sunspot 2833 and Sunspot 2834. Again, I can assure you the rotation of the sun didn't suddenly speed up like that. It would be accompanied by me being very freaked out. Here's a diagram of the solar system. This is where stuff is now. We've got a gibbous waxing. And there's where things will be in a week. It looks like a full moon coming. Spring is about to end, folks. Spring ends on Sunday night at 11:32 and 9 seconds. That's 11:32 p.m. We'll be streaming live for it. Anyway, here's a star chart showing the ecliptic. It's this yellow line, the path the sun will take across the sky. And up near the ecliptic are Jupiter and indeed Saturn. If you're up before dawn, you may be checking those out. The brightest objects in the sky. And if you don't know what the most intrinsically bright object visible from Earth is, it's this one right here, Cygnus X3, aka Deneb. And the 10.7 centimeter radial flux is only at 75. Radio flux at 75, the proportional data set to sunspot number. And there you can see how proportional those are. The upper line here, the black line, is the radio flux. The red line below it is sunspot number. And we don't see any forecasts here for any significant geomagnetic storms or anything like that, according to the Space Weather Enthusiast dashboard. So NOAA not forecasting anything, and I would tend to agree. We're also seeing a lull in 6.5 plus magnitude earthquakes. You can see the last 90 days here, showing the last 30 days. Quite quiet when it comes to 6.5 and larger magnitude earthquakes. They're reported in the 90-day bar graph by volcanodiscovery.com. So here's the last 24 on planet Earth in terms of 4 and 5 magnitude quakes. We see a number of 4 magnitude quakes, only a couple in the 5 plus range, one near Tonga and a deep one off the coast of northwestern South America. We'll get to it as we scroll up the list. Also, Hawaii saw a 4.5 right there under the southwestern flank of Kilauea. So onshore from some of the new real estate that's been created as a result of Kilauea's eruptions, a 4.5 magnitude quake is significant. especially if it is magmatic in origin. Estimated depth only 8 kilometers there of that quake. And I'm just going to continue up the list here. Largest of the past 24 was a 5.5 near Tonga. That one near the surface, estimated depth 10 kilometers. Also, Bloomingdale, Indiana saw a 3.8 magnitude quake. Please leave us a comment if you felt that quake. As we've got a number of viewers in the Midwest, shout out to our Midwestern viewers. And if we leave anything out during our earthquake coverage, just leave us a comment. We are more than happy to read all of those. Thanks everybody who leaves comments on the videos. Let's check volcanoes. So while Etna did erupt, it looks like it has ceased here for a bit. Karimsky, located on the Kamchatka Peninsula, may be erupting, but volcanic ash not visible in satellite imagery. Subanose Jima, 5,000-foot ash plume there. Fuego exploding in Guatemala, 15,000-foot ash plume there. Sangay in Ecuador, volcanic ash not observed. Please don't assume it's not erupting if you're hanging out in Ecuador. Revenador, also in that same nation, exploding, 16,000-foot ash plume there. Confirmed. Sabancaya exploding. Intermittent emissions are enough to produce a 24,000-foot plume of volcanic ash. And flight level 130 over Nevados de Chilean in central Chile as it explodes. Please do not pole vault the caldera. It could be unhealthful, and we need the views on YouTube. So make sure you press like and subscribe if you enjoy the content. And tell your friends and foes about the channel. smAshomash.com is where this public service message is derived. smAshomash.com, reminding you to not pole vault the caldera, since a lot of people are stupid. Literally half of the population, folks. The definition of stupid includes about half the population who are of below average intelligence. Getting back to the GOES 16 data here, it's the GOES X-ray flux. To see no major solar flaring over the past 24 hours. GOES proton flux also flatlined there. No coronal mass ejections headed our way recently. Although there are some coming, I would tend to forecast. Here's the GOES magnetometer over the past 3 days, looking a little bit more normal here as Earth has moved into the North Pole current sheet. And here's some visual analysis of that. The top view ecliptic plane field plot, part of the Gong 2 data, which is part of the National Sunspot Observatory, showing you the polarity of the heliospheric current sheet, the Parker spiral, whatever you'd like to call it. Red showing South Pole polarity, green showing North Pole polarity. And I would note also we've got some strong magnetism out here headed our way, so expect to see some higher readings on the GOES magnetometer. Just keep in mind the magnetic environment can suddenly change. Here's the line of sight view of the same data. We see some changes happening in the Sun's B field here. And here is the Sun's B field shown in blue. Those potential field surface source lines are the Sun's B field. Check out this coronal hole rotating in. It's North Pole oriented and it's trans-equatorial. Now, trans-equatorial coronal holes are the most geo-effective coronal holes. And if that remains intact, we can expect to see some geomagnetic activity as a result of that. It's quite significant, and it's behind some activity, so it's a little bit hard to see. The magnetic data does not lie. And again, let's go back to the Integrated Space Weather Analysis Center, the ISWA, the Integrated Space Weather Analysis Center, to look at the detected coronal holes and sunspot groups there, along with the solar magnetogram. Good times. Let's continue on. KP index currently at 2. Calm geomagnetic conditions currently. And next, the real-time solar wind, showing some errors, actually. You can see all this yellow stuff down here. Those are suspected errors when one of the two instruments here, either the ACE or the Discover, is detecting solar wind density below 1 proton per cubic centimeter. And that's what those yellow error bars are telling us. We see a fairly shifty BTBZ and a fairly shifty phi angle here over the past, at least the past 12 hours. Solar wind density here, pretty consistent, just under 5 protons per cubic centimeter. Solar wind speed still a little bit elevated here at 484 kilometers per second. Let's take a look at the magnetosphere. Here's magnetohydrodynamic pressure over the past 4 hours. It's our geospace magnetosphere movie. And the units here are in nanopascal magneto-hydrodynamic pressure. It's all based on the space weather modeling framework. It's courtesy of University of Michigan. And I've regained my ability to speak English. Next, looking at geospace delta B ground magnetic perturbations. Since we're living through a geomagnetic excursion, we show at least 4 hours of data daily. Anyway, there it is. We see pulses coming out of the Pacific Ocean once again, as well as perturbations over the Canadian North Pole, the South Geomagnetic Pole, which is someplace south of Australia, less so over the Siberian North Pole, and yes, there are two. Also geomagnetic perturbations here south of South America, as we've shown for years on the channel. We do regularly stream live to Twitch, and we'll be doing so for today's meteorology segment. Don't forget to check us out at twitch.tv/smAsho. There's a great mobile app that'll alert you when we go live. Also, thanks to our new YouTube subscribers, youtube.com/smAsho. Don't forget to check out our playlists, as we do a lot more than the daily space weather. And again, seriously, thanks everybody very much. We do consider the channel a collaborative effort. If you're watching the videos, especially leaving comments and so on, sharing the content with your friends and foes, you are already on the Smash team. Thanks for being there. We're also on BitChute. We've been uploading our meteorology segments to that platform, and we're counting down to the solstice here. We're in the 4 brightest days of the year right now. So make sure you join us when we stream live on Sunday night at 11:30 p.m. We'll be doing about an hour-long stream starting around 11 and ending around midnight to celebrate the onset of the June solstice. So summer arrives, and the sun starts getting lower in the sky at 11:32 and 9 seconds on Sunday night. Today's cosmology segment will be integrated into the daily space weather video. Here's the astronomy picture of the day, apod.nasa.gov, if you want to check that out. It's the horned sun of Moloch, folks. It's the scary, spooky, horned sun. And it's caused by distortions in the atmosphere, and from Belmar, New Jersey, which is actually one of the closest spots that we can view sunrises from our location. If you go due east from here, you're just north of Belmar. So that's a great little sunrise image there with some atmospheric distortion and some great colors. Some pink and some salmon and some mauve are included in the astronomy picture of the day. We're not going to pick anything random today. We're going to look at Cygnus X1. So this is the first object widely believed by cosmologists to believe it to be a black hole. It was famously bet on by Carl Sagan and Stephen Hawking back in the early 80s, I believe it was. And this was the first, again, this is the first object believed to be a black hole. We're looking at it at the low-end electromagnetic spectrum here. Infrared light on the 2-mass. Let's move up the spectrum a little bit and take a look at it on pan-stars, which is multi-wavelength optical light. And I think it is actually showing the companion here. This is a high-mass X-ray binary, folks, and it's quite bright in X-ray as well. Oops, let me go back to that. So here it is on the Chandra X-ray platform, and for some reason they only took a image of half of it here. For some reason, I don't know why they did such a thing. Here it is in infrared light, and it's not showing up. I apologize. The Galix is actually ultraviolet light. Anyway, here it is in blue light. You can see this little smear up here. That is likely the binary partner of this high-mass X-ray binary. If you want to follow the X-ray transients from Cygnus X1, they're interesting. You can find them on the Neil Gorell Swift-Bat X-ray Observatory. All you got to do is head to the Neil Gorell Swift-Bat X-ray Observatory and type in SIG space X-1. You'll find it. It's entry number 915. And we've actually seen some quite significant X-ray transient outbursts from it. So there's the daily chart. You can see we just saw, just a few hours ago actually, some significant X-ray output from Cygnus X1. And here it is over the last 30 days. You can see it's been ramping up in activity and emerging from a quiescent state here on the 16-year graph, the upper right. That's Cygnus X1. That's today's cosmology segment. It's integrated in the daily space weather. Don't forget to check our playlists, as we've got hundreds of cosmology segments. youtube.com/smashamash/playlists for all kinds of additional content. We've got an electron storm happening right now, and it's causing some charging hazards with satellites. So we see some satellite charging hazards here over the southern Pacific, Oceania, as well as the Caribbean, Central America, even some of Florida, seeing some charging hazards overhead. Here's the electron flux over the past year reported by Solon.info, and you can see this precipitous uptick in the electron flux as was forecasted. Yesterday we saw a brief period of electron flux warnings happen, and this electron flux warning level reached about 5 times the warning threshold, which is consistent with 1,000 pulse flux units. This is actually showing you density, which is different than a pulse flux unit. I won't get into the physics of that. It's the daily space weather. And patrons would already know that we've recently entered back into electron warning levels. Here's the NOAA forecast, and they're forecasting even higher levels of electron flux here. I would not tend to argue with that. And it's true, folks. Plasma travels like train cars through space. And once again, seeing here at the end of a coronal hole wind stream, a precipitous uptick in the electron flux. Yes, electrons are chasing those protons through space. Anthony Peratt would tend to agree, as I believe he's the guy who wrote about how plasma travels like train cars through space. Let me shrink that down one level. Here's the total electron content forecast, and we see more organized electron blobs here. This is showing you electron density through the entire air column. So that'll give you a good grasp of where GPS errors are most likely to occur. And again, we're seeing this a little more organized here with these higher levels of electron flux, perhaps giving us some insight into the induced magnetism of planet Earth, as electrons are very low mass and have a tendency to align themselves to potential field surface source lines. Here's a diagram of the atmosphere showing you the Van Allen belts. Feel free to pause. Distances are in miles. And next we're going to show the ionosphere. So the ionosphere is this F here, the red F. That's the F layer of the ionosphere, which breaks down into vibrational frequency. And we've been showing some anomalies the last couple days. Once again, seeing some anomalies here happening over Central South America and the South Pacific Ocean. So these areas right down here under my pointer, you'll see these charging up to high frequency levels right there. And that is anomalous, folks. The sun is north of the equator right now as we're just about to reach northern hemisphere summer. So those are some significant anomalies, and we've shown them at least 3 days in a row in the ionosphere. Anyway, there's the latest image coming in at 8:45 Universal Time. Looking a little odd there as well. One slice of the atmosphere located at around 300 kilometers of altitude. And we are going to do a meteorology segment, so make sure you join us for that. That will be a separate video. Let's do it! And we just did our meteorology segment. Make sure you tune into that if you haven't. You can find all of our playlists at youtube.com/smashomash/playlists. And let's do our bonus features. So here's the hydrogen alpha imagery. Hydrogen alpha imagery from El Teide, Spain, to show you filaments galore. You can see filaments out here, filaments over here. There are filaments suspended between the Earth and the Sun, and the likelihood of those to eject in what we call a coronal mass ejection, primarily made of hydrogen, is going to come blasting off the Sun in the near future. Sunspot 2834 does have the potential to produce some significant solar flares as well, as it is a beta-class sunspot. We'll show you the magnetic field orientation in a minute. Filaments, filaments, filaments. And here comes some additional bonus features. It's the GOES 16 SUVI thematic map. And there's nothing to explain here that we haven't already done so with. Here's the latest intensity gram. So there's Sunspot 2834. And we'll refresh the magnetogram as well. There you go. There's 2834. And you can see there are two different umbrae there. The leading one is North Pole oriented. The trailing one is South Pole oriented, making that a beta class sunspot. And as it sets, it does have the capacity to produce some significant solar flares. Sunspot 2833 is pretty basic. It's alpha class. It's only got one field. And there you can see the North Pole blue-colored umbra. And we'll close things out with some more solar imagery here. This is 304 angstroms ionized helium from the Solar Dynamics Observatory. Probably the best wavelength at showing filaments. And you can see some overlapping the northwestern limb there ahead of Sunspot 2834. Here's a close-up of Sunspot 2833 in two wavelengths here. You're looking at 304 angstroms and 171 ionized helium and ionized iron. And last but not least, the northwestern limb, the latest sunspot added to the solar system. It's Sunspot 2834. Thanks for tuning in, folks. Don't forget to press the share button. Leave us a comment. Tell your friends and foes about the channel. We'll see you next time. And may that solar wind be at your back. Daily Space Weather brought to you by Smash News Network. Least busted, name and news.